Higher Secondary Examination 2020. Subject Mathematics. Full marks 100. Pass marks 33. Time 3 hours. Attempt all questions. The figures in the right margin indicate full marks for the questions. Ye thangba nakanda lairiba figures sing asina questions sing asigi full marks sing tae. For question numbers 1 to 4, write the letter associated with the correct answer. Question 1 dagina 4 phawagi damaktadi achumba answer adugi chanaba letter adu iu. Question number 1. The identity element of the binary operation asterisk on R defined by A asterisk B equal to AB by 4 for all AB belongs to R is which one is true? Correct answer is C. How? A asterisk E equal to A implies, by definition of identity element, A asterisk E equal to A and A asterisk of E is AE by 4 and which equal to A. Dividing on both sides by A we get E equal to 4. But the correct answer is 4. But these R should be redefined as this R does not contain 0. If A is 0, which cannot be true. Question number 2. The value of sine of 2 tan inverse of 1 by 3 is? Answer B. How? Sine of 2 times of tan inverse of 1 5 equal to sine of 2 tan inverse of something can be converted into sine inverse is using this formula. We have sine of sine inverse, cancelling these two, we have this 6 by 10, that is 3 by 5. Correct answer should be B. For question number 3, the degree of the differential equation this is. The degree of this differential equation is 1. Correct answer is A, because third order is the highest order and its power is 1. The distance between the plane this and this is, these two planes are parallel, 2 by 2, 3 by 3, 6 by 6, they 3 are equal, therefore these planes are parallel. And distance between them is what? Distance between them is, using this C1 minus C2. Here C1 is 5 and C2 is minus 9. Minus of minus 9 is, we get this, and divided by square root of 2 square plus 3 square plus 6 square, we have 2. Therefore the correct answer is D, which is 2. What is meant by an equivalence relation? Equivalence relation I basically know. A relation R in a set A is an equivalence relation if R is reflexive, symmetric and transitive. For any square matrix A, prove that A transpose into A is a symmetric matrix. We have to take its transpose. We have transpose, so this is A transpose into A transpose of transpose whose value is A. And the transpose of this gives this itself. This shows that A transpose A is a symmetric matrix. For question number 7, find the value of K for which the function this is continuous at x equal to 0. This function is continuous at x equal to 0. It is given. We have to find out K. We have f of 0 whose value is K, which is equal to limiting value of this function, and taking limit we have 3. Therefore, K should be f of 0 is K. K should be 3. Number 8. If y equal to a sine of thrice x minus b cos of thrice x, find second order derivative in terms of y. 1 mark. We have to take its first order derivative dy by dx, whose derivative is this. For this we which is also this, and simplify we get this. Again, taking differentiating on both sides with respect to x, we have this, and which is minus 9 times of this, there is minus 1. Now we have expressed second order derivative in terms of y. Question number 9. Let R be a relation in and defined by A is related to B if 5 divides A minus B, where AB belongs to N. Prove that A related to B if implies A square related to B square. A related B implies 5 divides A minus B, and 5 divides A minus B into A plus B. 5 divides A square minus B square, which shows that A square is related to B square. Number 10. Evaluate definite integral, whose definite integral is sine inverse of x taking 1 0. We have sine inverse of 1 minus sine inverse of 0. We have pi by 2. If f of x equal to this, write down the value of f dash of x. F dash of x is x sin x. 12. What is meant by a linear differential equation of the first order? A differential equation of the form dy by dx plus py equal to q, where p and q are constants or functions of x, only is called a linear differential equation of first order. Define derivative of a function f at the point A. The derivative of a function f at the point A is the value of limit of f of a plus h minus f of a by h tends to 0 if it exists finitely. State chain rule for finding the derivative of a composite function. State chain rule for finding the derivative of a composite function. Let y is function y equal to f of u and u is z of x. Then dy by dx is dy by du into du by dx. This rule is called chain rule. Find the inverse of the function f from R to R defined by f of x equal to thrice x plus 1 by 2 for all x belongs to R2. Here f from R to R given by f of x equal to thrice x plus 1 by 2. We have to find out inverse. Let x and y belongs to R such that they two are not equal. Then these two are not equal, which is the value of f of x, which is also the value of f of y. Thus, for different two elements in a domain, there exist two different images in codomain. This shows that f is 1, 1. Let y equal to twice x minus 1 by 3, y belongs to R. This y should be in codomain and x should be in domain. Then solve x. We have this, which is always R. F is on 2. Thus f of x is bijective. For inverse, also f inverse of x is replace this x by f inverse of x, and since this y in x, we have this, which is the inverse of the given function. State Lagrange's mean value theorem and give its geometrical interpretation. 2 marks. If a function f is defined over the closed interval ab is such that it is continuous in the closed interval ab and it is derivable in the open interval ab, then there exists at least one point c belongs to open interval ab such that f dash of x equal to f of b minus f of a by b minus a. Its geometrical interpretation is if a curve representing a given function has a tangent at each of its points and the ordinates at the extremities a and b are not equal, then there exists at least one point c on the curve other than a and b, the tangent at which is parallel to chord AB, which is the geometrical interpretation of the Lagrange's mean value theorem. For question number 17, evaluate the value of this definite integral. 2 marks. This definite integral can be expressed as sum of two definite integrals, 0 to 5, 5 to I. For 0 to 5, whose value is minus times of x minus 5, 5 to I, whose value is x minus 5 itself. And taking its integral and evaluate these values, we have 17. Number 18, if A is any vector in space, so that a vector can be expressed a dot I times of I cap plus a dot j times of j cap plus a dot k times of k cap. Let a vector equal to a1 I cap plus a2 j cap plus a3 k cap. Then a dot I is this, and we have to apply a1 I dot I plus a2 times of I dot j plus a3 times of I dot k. I dot I is 1, I dot j is 0, I dot k is 0, therefore whose value is a1. Similarly, a dot j cap is L2 and a dot k cap is A3. Putting these values in the above, we have a vector equal to, instead of a1 we have to write a dot I cap, and instead of a2 we have to write a dot j cap, instead of a3 we have to write a dot k cap. Hence proof. What is meant by a homogeneous differential equation? Describe how it can be reduced to a form in which the variables are separable. 2 marks. A homogeneous differential equation is of the form dy by dx equal to f of xy, where f of xy is a homogeneous function of degree 0. Put y equal to vx so that dy by dx equal to v plus x dv by dx, and all substituting these values of y and dy by dx in the given differential equation, then it will be reducible to variable separable. Evaluate the value of this integral, 2 marks. So cos of twice x is equal to 2 cos square x minus 1, and cos twice alpha is equal to 2 cos square alpha minus 1. Can factorize and divide, we have this, whose integral is cos x, whose sin x, cos alpha is constant, and whose integral is x. This is the requirement. 21. Find the least value of k. Find the least value of k such that this is increasing for open interval 1 to 2 marks. Here f of x is equal to this, whose derivative is this. But x should be lying between 1 and 2. Multiply on 2 in its term, we have this, and 8 k in its term, we have this, and which shows that f of x is strictly increasing on open interval 1 to if 2 plus k should be greater than or equal to 0. Therefore 2 plus k should be greater than or equal to minus 2. Therefore 2 plus k equal to 0 gives k equal to minus 2. The least value of k is minus 2. 22. Find the equation of the plane through the point this and parallel to the plane this. We have to find out the equation of plane passing through this point and parallel to this plane. The equation of any plane parallel to the plane is this plane is r dot of this plus lambda equal to 0. This plane passes through the point this, therefore the coordinates of this point will satisfy the above equation, that is this, and from which we have to find out lambda, whose value is 13. Thus the required plane is, put lambda equal to 13, we have this. 23. Find the distance between the two parallel lines, this and this. These two lines are parallel as this equal to this equal to this, or this proportional coefficient of ijk in this equal proportionate to this. Here a1 is this, b is this, and a2 is this. We have to find out a2 minus a1, we get I cap minus k cap. The b cross of a2 minus a1, use this determinant and expand, we have this. Shortest distance d is, use this formula, put their respective values, evaluate, we get square root of 11 by 6, which is the distance between the two parallel lines. Question number 24. If cos alpha of this plus cos alpha of this equal to alpha, prove that this equal to this. 4 marks. Use this formula, cos alpha cos inverse x plus cos inverse y equal to cos inverse of xy minus root over 1 minus x square into 1 minus y square. Put their respective values, we have this. Transfer cos in the right side, we have this, and combine term these two terms and the root over term on the right side, squaring on both sides, we have this. Again expand and cancel this term with this and solve, we have this, and 1 minus cos square alpha is equal to sin square alpha, which proves the result. If x to the power a, y to the power b equal to x plus y equal to a plus b, prove that dy by dx equal to y by x, provided a y does not equal to bx. 4 marks. Taking logarithm on both sides, we get this, and differentiating both sides with respect to x, we get this, and combine the term containing dy by dx on left side, we have this. Solve dy by dx, cancelling bx minus ay because they two are not equal, and divide on in its term and solve dy by dx equal to y by x, which proves the result. Or if the function f defined by this is differentiable at x equal to c, find the value of a and b. We know that every differentiable function is continuous, so f is continuous at x equal to c. and we have 11 derivative at c equal to 9 derivative at c equal to f of c. Put their respective values. We have ac plus b equal to c square, which is equation 1. F is differentiable at x equal to c. It is also given, and its definition, by its definition, 11 derivative at 0 c equal to 9 derivative at c, and put their respective values and evaluate. We get twice c equal to a. We have to find out a and b. C is the given quantity, therefore the value of a is twice c. Put this value in the above Roman number 1. We get also 1 gives. We have b equal to minus c square. Thus a is twice c and b is minus c square. Prove that the integral of root over x square plus a square dx is this. 4 marks. We have to apply integration by parts. The first function is this, second function is 1. First function remains unchanged into integral of second function minus the integral of derivative of first function into integral of second function dx, whose integral is x and whose integral is this 1 by 2 root over x square plus a square twice x into integral of 1 dx dx, and we get this express numerator in terms of x square plus a square minus a square, and divide x square plus a square by root over. We have integrand of root over of x square plus a square dx, and minus a square, minus of minus a square is plus a square divided by this, which is equal to I, whose integrand is log of x plus root over x square plus a square, and transfer minus I on left side. We have this, divide by 2 in its term. We get this, which proves the result. 27. Evaluate the definite integral. For this, we have to put x equal to tan theta as 1 plus x square is, we have seen 1 plus x square, so we have to put x equal to tan theta, whose derivative is dx equal to sec square theta d theta, and as well as limit also change. When x is 0, theta is 0. When x is 1, theta should be pi by 4, and 1 plus tan square theta, which is equal to sec square theta, cancel this. We have log of 1 plus tan theta, and apply 0 to a property rule. Theta can be put in the form of pi by 4 minus theta, whose expansion is this. Sum up, we have this, which is again equal to log 2 minus log of 1 plus tan theta, which is what, which is equal to this, and which is equal to whose value is theta, that is pi by 4 log 2, which is I transfer on the left side. We have twice I, and therefore I becomes pi by I log 2, which is the requirement. 28. Find by integration the area of the region bounded by the parabola y square equal to 4ax and its latest rectum. 4 marks. Here y square equal to 4ax and latest rectum. Let L A0 be the focus, and LFL dash be the latest rectum of the parabola y square equal to 4ax. This parabola is symmetrical about x-axis, therefore we have two portions, or two equal portions. So require area of shaded region, which is equal to 2 times area of OFL, which is integral of root over 4x dx between 0 to a, whose value is this. And after evaluating, we get I by 3 a square units. Find by integration the area of the region enclosed between the curves parabola this and this. Here y square equal to 4x and x square equal to 4y. For point of intersection, squaring on both sides, we have this, and put x square equal to 4y. We have this, and factorize, we get y equals 0 or 4. The other factor cannot be real, no real root. When y equals 0, x equal to, when y equals 0, x equal to 0, when y equal to 4, x equal to 4. Therefore, the points of intersection are origin 0, 0 and P, whose coordinates are 4, 4. The required area of the shaded region, which is difference of two regions, and area formed by this parabola, this parabola on x-axis. then area this curve on this minus we get the required area, and we construct this definite integrand and evaluate and find out their value. 16 by 3 square units. 29. So that the general solution of the differential equation this is this, where a is an arbitrary constant 4 marks. Apply separation of variables. We have this, integrating both sides and add arbitrary constant c, and which can be put in this form, which is also can be put in this form, whose integrand is 1 by a tan inverse of x by a. Apply this. Similarly this, and cross multiply, we get this, then whose tan inverse x plus tan inverse y. Apply that formula, we have this, simplify, and tan inverse transfer on this side. On the right side we have tan of b, and a equal to this. Cross multiply, we get this, which proves the result. Obtain the equation of a plane in the intercept form. Obtain the equation of plane in the intercept form, 4 marks. Let the equation be this, where d cannot be 0. Question 1. Let the plane make intercepts small a, small b, small c on x, y, and z axes respectively. Then the plane meets x, y, and z axes at the point P, coordinate a 0, 0, q, 0, b, 0, r, 0, 0, c respectively as in this picture. Then the coordinates of this point will satisfy the above equation. For this we have this, and for this point we have this equation. For this point we have c. Substituting these values in equation 1, we get this. Divide and simplify, we get x by a plus y by b plus z by c equal to 1, which proves which is the required equation of the plane in intercept form. What is meant by a random variable? Define its probability distribution, mean, and a variance. Random variable. A random variable is a real value function whose domain is the sample space of a random experiment. Probability distribution of a random variable. Let x1, x2, xn be the values of the random variable x with respective probabilities p1, p2, pn. The probability distribution of a random variable x is the system of numbers x along this, p of x along this, where pi greater than 0. Summation of all pi should be 1, I from 1 to n. And the mean of x denoted by e of x or mu is defined as e of x equal to summation of xi pi I from 1 to n, or equal to x1 p1 plus x2 p2 plus xn pn. Variance. The variance of the random variable x is denoted var x or sigma x square and is defined as variance of x equal to summation of xi minus mu whole square into p of xi I from 1 to n, or variance x equal to e of x minus mu whole square. If a equal to this, so that this matrix equation equal to 0 and hence find a inverse. We have to find out a square, and multiplication we get this. For aq we have multiplied this to we have this. Put these values on the left hand side, we have, and simplify. Lastly we get 0 matrix. Hence the matrix A satisfies the matrix equation, from which we have to find out a inverse. For second part, we have this I equal, from which we have to solve I, and a inverse, multiply a inverse on both sides. We have this inverse equal to this, and put a square here for a, for I, and simplify, we get this, which is the inverse of the given matrix using the relation obtained above. 33. So that the right circular cone of least curved surface and given volume has an altitude equal to √2 times the radius of the base. 6. As in this picture. Let S V R L is be the curved surface area given volume, radius, land height, and altitude of the cone. Then S equal to pi R L, V equal to 1 by 3 pi R square, is L square equal to A square plus R square. S squaring on both sides, we have this S square. I have put S square equal to Z, and L square is equal to this. Put is equal to from which solve is, and whose square is this, and lastly we get this. Now Z is function of R, only B is given, and dz by dr, we have this. Again differentiating this with respect to R, we get this. For now we have to put dz by dr equal to 0, that is this equal to 0, and for solve we have R equal to I by root 2. When R equal to I by root 2, the value of second order derivative is greater than 0. That is always positive, because these terms are positive as well as terms containing variables are always square. Thus Z or S is least when R is I by root 2. That is I equal to root 2 times of R. That is I is altitude, R is radius, root 2 times of radius, henceforth. 33. Or the point on the curve x square equal to twice y, which is nearest to the point this. Let P x y be a point on the curve this, which is nearest to the point Q. Let S be the square of the distance between P and Q. Then S equal to, using distance formula between this P and Q, we have this, and also we have learned that the coordinates of this point will satisfy this equation, that is S square equal to twice y. Now convert S in terms of y, we have this. Now ds by dy, differentiating this with respect to y, this again differentiate this with respect to y, we get this. Now ds by dy equal to 0 gives y equal to 4. When y equal to 4, second order is always greater than 0, positive. Thus S is least when y equal to 4 and S equal to square root of 2 into 4, that is 2 root 2. Thus the nearest point is 2 root 2, 4. 34. Solve the following system of equations by matrix method. We have x equal to b, where is coefficient matrix, and x is scalar matrix formed by unknowns, b is scalar matrix formed by constant. Now we have to find out determinant of a whose value is 7, which does not equal to 0, therefore inverse exists. And hence multiply inverse on both sides of this equation, we get x equal to a inverse b. We have a1 1 cofactor of this element 1 and cofactor of 1 this element 2, we have this. Solve similarly first row, second row, third row, and adjoint a is this, and a inverse is 1 by determinant into the value of the adjoint. X equal to a inverse b gives x is this and a inverse is this, b is scalar matrix this, multiply and simplify and equating this, x equal to 1, y equal to minus 5, z equal to minus 5. These are the required solutions. Prove by vector method that the internal bisectors of the angles of a triangle are concurrent. Internal bisectors of the angles of a triangle are concurrent. 6 mark. Let PQR be the position vectors of the vertices ABC of triangle ABC. Then let BC equal to ACA equal to BAB, length of the side equal to C. If AD, the internal bisector of angle A, meets BC at D, then BD is to DC equal to AB is to AC, that is C is to B. So the point D divides BC in the ratio C is to B, and the position of vector position vector of D is position vector of D is, this should be said, of D is BQ vector plus C times of R vector by B plus C. We have known the position vector of D. If the point I divides AD internally in the ratio of B plus C is to A, then the position vector of I is, using section formula for internal division, we have this. By symmetry of this result, the point I lies on the internal bisector of each of the two other angles. Hence, the internal bisectors of the angles of a triangle are concurrent. 35. Or prove by vector method that in any triangle ABC, this 6 marks. We have to draw this triangle as in this picture. Let BC vector equal to AC, A vector equal to B vector, A B vector equal to C. Then their sum should be 0 vector pre-multiply by a vector. We have this, and whose expansion is this, which is 0. A cross A is 0. We have A cross B equal to minus A cross C, and which is equal to C cross A. Similarly, we can prove that B cross C equal to A cross B and C cross A equal to B cross C. Therefore, A cross B equal to B cross C equal to C cross A. Their modulus is this, and whose values are A, B. Sine of angle between A and B, A vector and B vector, is sine of pi minus C. Similarly, angle between B and C is also sine of pi minus A. Angle between C and A is also pi minus B. Their value remains unchanged. Divide in sum by product of small a, b, c. We have, and convert it in the standard form. We have this, which proves the result. 36. In a ball factory, machines A, B, and C manufacture respectively 60%, 25%, 15% of the total balls respectively. Of the total of their output, 1%, 2%, and 1% are defective balls. A ball is drawn at random from the total production and found to be defective, from which machine the defective ball is expected to have been manufactured. Let H1, H2, H3 be the events of selecting a ball produced by machines A, B, and C respectively. Let E be the event of drawing a defective ball. Then P of H1 is this, P of H2, P of H3. P of E by H1, P of E by H2, P of E by H3. We get this. The required probability is P of H1 by E is this Bayes theorem. We have this. Similarly, using P of H2 by E using Bayes theorem and putting their value, we have this. And using P of H3 by E, we have 3 by 25. From which these three values, which one is greater? Hence, most probably the defective ball has been drawn from the output of machine A. 36. A box contains 10 items, out of which 2 are defective. A man selects 3 items at random. Find the expected number of defective items he has drawn. A box contains 3 items, out of which 2 are defective. A man selects 3 items at random. Find the expected number of defective items he has drawn. 6 marks. Let X be the defective items drawn. Then X can take value 0, 1, 2. Also, P of X equals 0. P of no defective item. There is I 63 by 10, 63. We have 7 by 5. Similarly, P of X1 is also this. P of X2 is also this. The required expected number of defective items drawn is this. Put their respective values. We have 9 by 15. Again, consider we have 3 by 5. Question number 37. An industry manufactures toy cars and cycles. It can invest rupees 8,900 in both of them. A car costs rupees 450 and a cycle costs rupees 350. It has a storage capacity of 22 items only. If its profit is rupees 60 per car and rupees 50 per cycle, how many of it should be manufactured so that the profit is maximum? Find also the maximum profit graphically. Let X and Y be the number of toy cars and cycles to be manufactured respectively. The problem is to maximize Z equals 60X plus 50Y, subject to the constraints 450 times of X plus 350 times of Y less than equal to 900, and X plus Y less than equal to 22, X greater than equal to 0, Y greater than equal to 0. The graphs of the corresponding equations are drawn. The feasible region is the shaded region with vertices O, whose coordinates are 0, 0, at A, whose coordinates are 19.70. Here it is 19.7, here it is 19.8. And P, whose coordinates are 12, 10. And D, whose coordinates are 0, 22. At O, the value of Z is 0. At A, the value of Z is this. At this, therefore it must be I. at dw, this is which should be maximized. Z should be maximized. Maximum value of out of these four, maximum is this. Thus the required number of cars and toy cars are 12 and 12 and 10. And also the maximum profit is rupees 1220. Thanks for watching.